Test-driven development, or TDD, is a software development approach where tests are written before writing the actual code. It is a cyclical process that ensures code quality, reduces bugs, and improves the overall design of the software. In TDD, you write a test first that defines a specific functionality. This test initially fails because the code to implement the functionality doesn't exist yet. You then write the minimum amount of code to make the test pass. Once the test passes, you refactor the code to improve its design and readability. Imagine you're building a house. In TDD, you wouldn't start by laying bricks randomly. Instead, you would first create a blueprint, the test, that outlines the desired structure. Then you would build each component of the house, constantly referring to the blueprint to ensure everything fits together correctly. TDD is like having a safety net while you code. It gives you the confidence to make changes to your code base, knowing that any regressions will be caught by the tests. By writing tests first, you are essentially defining the expected behavior of your code up front, leading to a more robust and maintainable software product. The red-green refactor cycle is the heart of test-driven development. It guides developers through the TDD workflow. The cycle consists of 3 phases: red, green, and refactor. 1. Red, write a test that specifies functionality. This test is designed to fail initially. 2. Green, write code to make the test pass. 3. Refactor, improve the code's design. Repeat this cycle for each new feature. Test-driven development offers numerous benefits, making it a valuable practice for software development teams of all sizes. Here are some of the key advantages of adopting TDD. 1. Improved code quality. TDD forces developers to think about the desired behavior of the code before writing it, leading to better code design and fewer bugs. 2. Increased confidence in code changes. With a comprehensive suite of tests, developers can make changes to the codebase with confidence, knowing that any regressions will be caught by the tests. 3. Better design. Writing tests first encourages developers to design more modular and loosely coupled code, resulting in a more maintainable and extensible codebase. 4. Reduced debugging time. Since tests are written up front, bugs are caught early in the development process, reducing the time and effort spent on debugging. 5. Living documentation tests serve as living documentation of the code, clearly outlining the expected behavior of different components and functionalities. By embracing TDD, development teams can deliver higher quality software, reduce development time, and improve overall productivity. While TDD offers numerous benefits, developers may encounter some challenges when adopting this practice. Here are some common challenges and best practices to overcome them. Challenge writing tests can feel time-consuming initially. Best practice. Start with small, manageable tests and gradually increase the complexity as you become more comfortable with TDD. Challenge. Identifying the right level of test granularity. Best practice. Aim for a balance between unit tests that cover individual components and integration tests that verify interactions between different parts of the system. Challenge. Dealing with legacy code that lacks tests. Best practice. Start by writing tests for new code and gradually add tests for existing code as you make changes or refactor. Challenge. Maintaining tests as the codebase evolves. Best practice. Refactor tests along with the code to ensure they remain relevant and useful. By following these best practices and addressing challenges proactively, developers can successfully integrate TDD into their workflow and reap its numerous benefits.